When building out zero-emission mobility powered by batteries, you need the best electric motor to provide the rotational energy that produces motion. Tesla has become good at developing its own motor, and it shows in the level of success its cars have achieved globally. However, Elon Musk has not been resting on his laurels, as he's been pushing Tesla to develop even better electric motors. The latest result is a new engine that defies the laws of physics. What is this new engine, and how does it beat the whole EV industry? Join us as we explore the new engine revealed by Musk and Tesla that defies the laws of physics. We live in the electric cars age, and Tesla commands a huge slice of the action. After centuries of relying on the internal combustion engine that has caused untold damage to the environment due to the carbon emissions it produces, the Texas-based company is leading humanity's attempt to shift to zero-emission mobility. Thanks to the visionary Elon Musk, we've come to accept electric cars as a practical means of getting around, and many of the kinks are being worked out. While everybody knows Tesla uses lithium-ion batteries to power its cars, what may not be commonly known is the type of electric motor the company uses and why it settled for the choice that it did. Tesla uses a three-phase AC induction motor instead of a DC motor. Given that the lithium-ion battery is DC, you may wonder why the EV maker is not using DC motors. There are multiple reasons, including that AC induction motors have more torque even at higher speed, have a simple design, are cost-effective, do not need rare earth minerals-rich permanent magnet, have high reliability, and have an easier regenerative braking system design. How come? We will briefly explain why. There are various motors, such as DC motor, brushless DC motor or BLDC, AC induction motors, stepper motor, and more. Most household electronics used a brushed DC motor, such as toys, electric toothbrushes, razors, and so forth. However, due to friction, the middle rotating part, or rotor, wears out over time. Therefore, after a few hundred hours of operation, these motors fail and need the contactor replaced. Also, if the controller fails, it can either open or short the motor coil. A shorted coil would lead to a runaway situation. So for an electric vehicle with the intense performance expected, brushed DC motors are not a wise choice. What about BLDC? Well, the brushless DC motor has a high initial starting torque, but its performance or efficiency decreases linearly when speed increases. This means if an electric vehicle uses a BLDC motor, the car will use significant electrical energy at highway speeds. In addition, at high speed, your vehicle would respond slower to your accelerator input. The Toyota Prius has a bad reputation that it can't accelerate fast enough. The primary reason for the slow acceleration is that Toyota uses DC brushless motors in the Prius lineup. Before Tesla, everyone used to bash electric vehicles for their slow performance. The slow speed of these EVs is also related to DC motors. But that is not all. Another reason has to do with rare earth minerals. To make a good DC motor, you need strong permanent magnets. And to make these strong permanent magnets, you need rare earth minerals. Before the 1980s, the US had rare earth element industries, especially in California. However, in the 1980s, most of these companies moved to China to take advantage of low labor costs and environmental restrictions. Since then, China has controlled more than 90% of refined rare earth minerals globally. Musk realized that when a single country controls an essential element for a product with no alternative, it could become a bottleneck for future car production. In 2010, it became clear that Elon made the right choice by not using the DC motor, which uses rare earth elements. That year, China banned the export of rare minerals to Japan over a diplomatic dispute and tried to crush their economy. As a result, companies in other countries started stockpiling rare minerals to secure supply. It led to a massive price spike. So for a company planning to make millions of electric cars in a year, DC motors are not the right choice. The advantage of the AC induction motor is its torque property is very close to the ideal characteristic. This motor's torque is constant up to a certain speed and then decreases, unlike the DC motor. The induction motor does not have permanent magnets, no brushes, no commutator rings, and no position sensors. Its design is simple and has a rugged construction. An EV that uses a BLDC motor on a highway is less efficient than an EV with an AC induction motor. Another benefit of the induction motor is the easier and simple regenerative braking system design. In the DC motor case, the system is very complicated compared to an induction motor. Tesla clearly got a lot right with the Model 3's powertrain. It gave its motor designer team, if not a blank check, a blank whiteboard, and the team came up with an electric motor suitable not only for an affordable electric car, but also for the upcoming Tesla Semi. Tesla's chief designer Konstantinos Laskaris joined Tesla after the Model S had been developed. His head must have been full of fresh ideas from when he co-founded a project to design and build an efficient electric car. The 3's motor design helped Tesla towards its stated goal of a 25% reduction on parts count by having the motor do double duty as a heat source for warming the traction battery. Meanwhile, Tesla is not satisfied yet with the performance of its electric motor, as it believes it can squeeze out even more performance from the component. The result of its unrelenting effort on its electric motor is that the Model S Plaid became the fastest production car globally, with performance that puts cars that cost much more than it to shame. The key to reaching this achievement was the carbon-sleeved motor, with the highest torque and super high revolutions per minute (RPM). However, the Model S Plaid is not the only car to benefit from the Wonder electric motor, as Tesla plans to tweak it further for more performance in the new generation Roadster. Musk shared unique details about the new innovative motor. The new electric motor is the first to be in production and features carbon sleeve rotors. Tesla had to overcome some serious obstacles to get the carbon wrapped over the rotor. Musk explained that carbon and copper have different thermal expansion rates, and to achieve the desired result, the rotor must be wrapped at an extremely high intensity, which was difficult to do. The Tesla CEO said that the fiber is wound over the rotor at a high tension load, which was previously impossible on a large production scale. Tesla Automation, based in Germany, made a machine for this. Tesla had to build a new facility near Tesla Automation's existing facilities at Prüm. This is where the production lines for new machines needed to produce the innovative motors that will power the Model S Plaid and Roadster. The main benefit of the new motor is that the carbon sleeve rotor creates a stronger electromagnetic field than a rotor that is held together by metal. Another advantage is that the rotor can go to higher RPM, as the carbon sleeve stops the copper rotor from expanding due to radial acceleration. Thus, Tesla's new motor is the most advanced motor in production on Earth. Tesla has a bevy of new vehicles hitting the market soon, including heavy-duty ones. There is the Roadster, for example, which, as stated earlier, Tesla will tweak the new carbon sleeve motor for. It will produce a blistering acceleration from 0 to 60 miles per hour in less than 2 seconds. Of course, Tesla wants to step that up with a SpaceX package, but it hasn't been confirmed the car will use the new electric motor. There is also the Cybertruck, which was initially revealed in 2019 to use a tri-motor setup on its highest trim that will do 0 to 60 miles per hour in 2.9 seconds. However, Tesla is now promising a 4-motor configuration that will be more powerful. By using the new carbon-sleeved electric motor, Tesla can make the Cybertruck an even more powerful and faster pickup truck. Tesla is also prepping the Semi-Truck, a Class 8 electric truck that uses 4 electric motors. The truck was thought to use the same motors as the Model 3. However, by using the new carbon-sleeved electric motor, Tesla can make the truck even more capable. This is necessary for Tesla to be successful in luring truck fleet operators to transition their operations to electric trucks. Beyond road vehicles, the new carbon-sleeved motor can show up in an electric plane, which Musk has repeatedly said he is looking forward to designing. Let's hear what you think of the carbon-sleeved electric motor in the comments section below.